Good morning, everyone. We are from Tutorial Group 4. We are going to discuss the questions for tutorial estimation and confidence interval. My name is Tianjia Min. Our group members are Yak Hui Wen, Noor Shamimi Jahira binti Ismail, Noor Fatin Julaika binti Zulkifli, and Nazurin Azra binti Noor Hazlan. Now we proceed to question 1. Question 1. Explain the various alternatives for decreasing the width of a confidence interval. Which is the best alternative? The width of a confidence interval can be determined by the sample size, variation in the data, desired level of confidence, and the type of interval. To decrease the width of confidence level, the alternatives are by increasing the sample size, reduce the variability in the population, lower the desired confidence level, and use one-sided confidence interval. The best alternative is by increasing the sample size. The more observations that are available, the narrower the interval around the sample statistic is. Thus, we can often collect more data to obtain a more precise estimate of a population parameter. Question 2. For a population, the value of the standard deviation is 2.35. A sample of 35 observations taken from this population produced the following data. Question. Construct a 98% confidence interval for mean. The formula is mean plus minus z value times standard deviation divided by square root n. First, we find the sample mean. The sample mean is the sum of all the values in the sample divided by the number of values in the sample. Then we can get 38. The standard deviation given is 2.35 and the number of observations is 35. Now we can count the z value. The z value is equal to 1 minus 0.98 divided by 2 because of the left and right side. We can find 0.01. In the table 4, we will obtain the value 2.3263. So, after we get the answer for the z value is 2.33, the 98% confidence interval is 38 plus minus 2.33 times 2.35 divided by the square root of 35. We can get two answers because of the positive and negative sign. We get the answer 38.9255 and 37.0745. In conclusion, the level of confidence is 98% and the confidence interval limits are 37.0745 and 38.9255. That's all for me. Thank you.
Hi, I'm Fatim. I'm going to discuss question 3. So for question 3, it stated that Lazarus Steel Corporation produced iron rods that are supposed to be 36 inches long, but it does not exactly 36 inch long per rod. So from the question, the mean stated is 36 inches and the standard deviation is 0.1 inch. The question asks us to calculate the mean of the rod and make a 99% of confidence interval for the population mean. It stated also if either the upper limit of this confidence interval is greater than 36.05 inches or the lower limit of this confidence interval is less than 35.95 inches. And the sample mean of 20 is 36.02 inches. So the question is, based on this sample, will you conclude that the machine needs an adjustment? and assume that the length of all such roads have a normal distribution. So step 1, we have to construct confidence interval. Confidence interval is written in the form sample mean plus minus margin of error. The sample mean is the point estimate for the population mean. Since the sample size is large and the population standard deviation is known, we will use the following formula and determine the z-score from the normal distribution table. Margin error equals to z times population standard deviation divided by square root number of sample. From the information given, the sample is 36.02 inches, the population standard deviation is 0.1 inch, and the number of sample is 20. So step 2, we need to determine the z-score. So we subtract the confidence level from 100% to get the alpha. So alpha equals to 1 minus 0.99 equals to 0.01. Alpha divided by 2 equals to 0.01 divided by 2 equals to 0.005. This is the area in each tail. Since we want the area in the middle, it becomes 1 minus 0.005 equals to 0.995. The z-score corresponding to the area on the z-table is 2.58. Thus, the confidence level of 99% is 2.58. We calculate first margin of error 2.58 times 0.1 divided by square root of 20, and then we get 0.058. To find the confidence interval for lower and upper limit, we put all the information given into the formula. Confidence interval equals to sample mean 36.02 plus minus margin error 0.058. So for the lower limit of the confidence interval is 36.02 minus 0.058 equals to 35.96 inches. And for the upper limit of the confidence interval is 36.02 plus 0.058 equals to 36.08 inches. Since 36.08 is greater than 36.05, then we would conclude that the machine needs adjustment. So that's all for question number 3.
Question 4. Jack's Auto Insurance Company customers sometimes have to wait a long time to speak to a customer service representative when they call regarding disputed claims. A random sample of 25 such calls yielded a mean waiting time of 22 minutes with a standard deviation of 6 minutes. Construct a 99% confidence interval for the population mean of such waiting times. Assume that such waiting times for the population follow a normal distribution. For question 4, the question already gave us the sample mean, which is 22 minutes, and the standard deviation is 6 minutes, and the sample size is 25. For the remaining confidence interval is equal to 1%. So 1% equals to 0.01, and we have to divide it by 2 to know each side's tail from the distribution graph. So each side tails value equals to 0.005. From the question doesn't give us the standard deviation of population. So we will use the t distribution formula this. This is the formula. So t is equal to n minus 1 and equals to 24. Therefore, from the table, the t value distribution is equal to 2.797. So to find the value, we need to insert the value that we found in the formula. So we will get the 22 plus minus 3.3564. So if 22 minus 3.3564, we will get 18.6436. And if we plus it, we get 25.3564. So in conclusion, the range of customers' waiting time is between 18.64 until 25.36 minutes to speak to customer services.
Thank you, Zurin. Hi, everyone. My name is Shamimi, and I will explain to you guys about question 5. The management of a health insurance company wants to know the percentage of its policyholders who have tried alternative treatments. A random sample of 24 of the company's policyholders were asked whether or not they have tried such treatments. The following are their responses. So from the question, we know that a random sample of 24 of the company policyholders is the sample size. And we also know that 8 policyholders respond yes and 16 policyholders respond no. So I will answer the question 5A and 5B in the next slide. 5A, what is the point estimate of the corresponding population proportion? So we know that point estimate is something that we can derive from the sample. So to find the answer, we need to use sample proportion formula, which is P equal to X divided by N, which is P stand for sample proportion, X stand for number of policyholders respond yes, and N stand for sample size. So at the previous slide, we know that sample size is equal to 24 and number of policyholders respond yes is equal to 8. So we just insert the value into the formula. P equal to 8 divided by 24 and we get P equal to 0.33. In the conclusion, the company estimates that 33% of policyholders will try the alternative treatments. 5B, construct a 95% confidence interval for the percentage of these company policyholders who have tried alternative treatments. So at 95% confidence interval, we can count like this. 1 minus alpha times by 100% equal to 95%. 1 minus alpha equal to 0.95. And we get alpha equal to 0.05. We need to divide alpha by 2 because as you guys can see in the graph, we have two sides of tail, which is we have right tail and we have left tail. So we need to divide alpha by 2. 0.05 divided by 2, we get 0.025. So to find the value for confidence interval, we need to look at statistical table at table 3, and I found 0.025 at 1.96. So the value for Z, or confidence interval, is 1.96. So to calculate confidence interval for population proportion, we use this formula. At the previous slide, we know that P equal to 0.33, N equal to 24, and we also know the value for Z, which is 1.96. So we just insert the value into the formula and we calculate and we get the answer 0.142 and 0.518. So in the conclusion, the confidence interval limits are 0.142 to 0.518. The health insurance company will estimate with 95% confidence that all policyholders have tried alternative treatments between 14.2% to 51.8%. So that's all from me. I will pass to the next presenter. Thank you.
Question 6. An alumni association wants to estimate the mean debt of this year's college graduates. It is known that the population standard deviation of the debts of this year's college graduates is $11,800. How large a sample should be selected so that the estimate with a 99% confidence level is within $800 of the population mean? From question 6, the question is basically asking us to find the sample size, which is the n value. So first we already find the standard deviation, which is 11,800 from the question right here. And then we need to find the confidence level, which is 1% equals to 0.01, and we have to divide it by 2 equals to 0.005, just like question 4 before. Therefore, from the table, we can get the Z distribution value, which is 2.576, that we can find it down here. And so the desired margin of error, E equals to 800. Now we want to find the sample size. The sample size we can find it by Z distribution times standard deviation divided the desired margin of error, and we bracket it all and we square it all of the value. So we put in the value, the numbers in the formula. So we calculate it, we get 1443.696. So we round it up, we'll get 1,444 college graduates. So in conclusion, the sample size should be 1,444 college graduates.
Question 7. Lombard Electronics Company has just installed a new machine that makes a part that is used in clocks. The company wants to estimate the proportion of these parts produced by this machine that are defective. The company manager wants this estimate to be within 0.02 of the population proportion for 95% confidence level. What is the most conservative estimate of sample size that will limit the margin of error to within 0.02 of the population proportion? So for this question, we will use this formula, which is n equal to p multiply 1 minus p multiply z divided by e squared. N is the size of sample, Z is the standard normal value corresponding to the desired level of confidence, while E is the maximum allowable error. We get to know P equal to 0.5, Z equal to 1.96, and E equal to 0.02. How do we get to know P equals to 0.5? It's because for the most conservative estimate of a sample size, we use P equal to 0.5. The value of Z for 95% confidence level is 1.96. We can find this from a normal distribution table. Firstly, we can draw a normal distribution graph. The 95% of the confidence level is at the middle, and the remaining 5% will be divided equally and put at the right and the left of the tail. Next, to find the Z value, you may refer to the normal distribution table at the right. Based on the number 0.025, we got this before, we get to know that the value of Z is 1.96. After we got all this information, we can use the formula to find the value of N, and we will get 2401 for the value of N. In conclusion, if Lombard Electronics take a sample of 2401 parts, there is 95% chance that the estimate of P will be within 0.02 of the population proportion.
That's all from us. Thank you.